All right, let's dive in. Today, we're deconstructing the master plan for software that simply cannot be allowed to fail. We're talking about the code that runs fighter jets, life support systems, you name it. And at the heart of it all is a document called the Software Design Description. So let's just stop and think for a second. How do you even begin to build software for something like that, where a single bug, a single tiny error, could have catastrophic consequences? You definitely don't just start writing code and hope for the best.
No, you start with a master blueprint. I mean, seriously, imagine trying to build a skyscraper without one. You wouldn't just tell the construction crew to show up and start welding beams together, right? Of course not. You'd have an incredibly detailed architectural plan that maps out everything, from the foundation deep in the ground to the very last window pane. Well, for software that matters, it is exactly the same principle.
And in this world of high-stakes software, that master blueprint has a name. It's called the Software Design Description, or SDD for short. This document is the absolute, definitive guide for how that software is going to be built. So what is this thing really? Well, according to the military standard it comes from, the SSD is all about describing the design of a computer software configuration item, which I know is a mouthful. It's just a formal way of saying a big, important piece of software. And this document covers everything, from the 30,000-foot architectural view all the way down to the tiny details a programmer needs to actually start writing the code. Now, what's really crucial to get here is that this blueprint has two jobs. It serves two masters, so to speak. On the one hand, yeah, it's the instruction manual for the developers who are actually building the thing. But, and this is just as important, it gives the client, the people paying for it, a crystal clear window into the entire design. It's a communication tool, it's a contract, and it's what ensures the system can be maintained and supported for years to come. Okay, so where do you even begin with a document this massive? Well, think back to our skyscraper. Before the architect starts drawing out every single office, they have to make some big foundational decisions that affect the whole building. The SDD starts in exactly the same place. This first part is all about what they call CSCI-wide design decisions. And the key phrase to hang on to here is from a user's point of view. Right now, we are not worried about the code on the inside. We are defining how the software is going to behave on the outside and the fundamental rules it has to live by. So, using our building analogy, this is like deciding where the main doors and loading docks are going to be. That's your input and output. It's like designing the layout of the public lobby. That's your user-facing database design. It's figuring out the building's fire escape plan and security system. That's how you handle safety, security, and errors. And, super importantly, it's listing all the city utilities the building needs to function, like the power grid or water supply. In the software world, those are your external libraries and dependencies. All right, once those big, high-level rules are locked in, it's time to start drafting the internal architecture. We're moving from the outside view of our skyscraper to mapping out its internal structure. If that last section was the architect's grand vision, this part is the detailed floor plan for every single level. This is where you break the entire massive software project down into smaller, more manageable parts. You're defining every room, what it's for, and exactly how it connects to all the other rooms. Now, the official term for these building blocks is a software unit, and it's a super flexible term. A unit could be something huge, like an entire wing of the building, say a major module, or it could be as small as a single light switch, like one specific function. The whole point is to take a giant, complex problem and break it down into a hierarchy of smaller and smaller pieces until you can actually wrap your head around them. And the level of detail they're asking for here is just wow. You have to identify every single software unit, you have to show how they're all related, and you have to map out the dynamic flow of how data and control move between them. It's not enough to just say what the rooms are, you have to describe how people walk through the hallways. The plan even has to say which client requirement is being handled by which unit, and how much of the computer's resources, like its CPU power and memory, each part is allowed to use. So we've got our big rules, we've got our floor plan, now we get into the really deep technical stuff, designing the connections that make everything work together as one cohesive system. This is all about the interfaces. And honestly, this is where that skyscraper analogy just clicks perfectly into place. This part of the document is the software's version of the schematics for the building's plumbing, its electrical wiring, and its ventilation systems. It defines with absolute precision how every single unit talks to every other unit and to the outside world. And this is where you see just how ridiculously precise the SDD is. It's not enough to say,
hey, component A sends some data over to component B. No way. The SDD makes you define every last characteristic of that data. I mean, just look at this table. For a single piece of information, you have to define its data type, its valid range of values, any security rules, even its units of measurement. This level of insane detail is how you prevent mistakes and make sure every piece of the puzzle is speaking the exact same language. Okay, after all of that design work, from the big picture decisions all the way down to a single piece of data, there is one final absolutely critical check. You can think of it as the ultimate quality control step for the entire blueprint. It's called requirements traceability, and it's basically an audit trail. This section is a giant map that connects every single requirement the client gave you directly to the specific software unit that was designed to make it happen. It's proof. It's how you can look the client in the eye and say, see this thing you asked for? Here. Here is exactly where we built it in the design. It ensures nothing, absolutely nothing, gets forgotten. So you might be thinking, wow, that is an insane amount of work. Why on earth would anyone go through all this trouble? Why does this blueprint matter so much? Well, the value is just immense. First, the rigor forces a kind of discipline that prevents you from making sloppy, dangerous mistakes. Second, the clarity of it creates a single source of truth, so everybody, from the client down to the newest programmer, is on the exact same page. Third, that traceability provides undeniable accountability. And maybe the most important thing of all is maintainability. This document makes it possible for a whole new team of people to come in years later, understand the system, and keep it running long after the original creators have moved on. And that really brings us to a huge question for today's software world, which is all about being agile and moving fast. Is a document like the SSD, with all its upfront planning, just an old relic from a bygone era? Or, as our systems get more and more complex, is this kind of hardcore, disciplined blueprinting actually a rediscovered necessity for building things that are meant to last? It's definitely something to think about. Thanks for tuning in.